talk about MWorks and CPS simulation from the three parts. The first one, I will give the brief introduction. About the CPS, it's not a new concept, but here the CPS have two meanings. The first one is a system consists of cyber part and the physical part, and the second meaning, the CPS is a cyberspace and the physical space, the mapping, that means the digital twin. So about the CPS computing and simulation, firstly, the modality, the CPS needed the unified multi-domain physical modeling and cyber presentation. The second, the CPS needed the seamless cyber-physical integration and closed-loop cyber-physical simulation. The third, the CPS needed the support in real-time code generation and the digital twin. So first, the modality provides a very tool for the CPS. The multi-domain physical unified modeling is widely adopted. But as for the block diagram modeling, the modality face some challenges. Firstly, they cannot support the block debugging. The block and the generated code cannot by direction tracing. So, for this, the CPS, Open Modelica and the Julia Hub, so integration, the scientific computing and Modelica, such as Open Modelica, integration, the scientific computing ability of Julia. And the Julia is also contain the ability of Modelica. And there are some commercial tools support scientific computing and system modeling and simulation, such as MATLAB and Simulink, Maple and MapleSim, Mathematica and the system modeler, including also the MWorks. Yeah, I want to introduce the MWorks, how to support the CPS. So about the MWorks, the MWorks have a long history. The first commercial version was released 2009, and from the time we have been focused improvement of MWorks. So the MWorks before the 2020, MWorks is a pure modelic tools support system modeling and simulation. It has been used in aerospace, aviation, energy, automobile, shipping, and education. From 2020, so I want to have better support to CPS, so we integrate the Julia ability to support the cyberspace. So in 2022, we released the first version of SysLab, which is scientific computing environment. And in 2024, we have a complete platform, including the scientific computing and system modeling and simulation tools together. So I will also give a brief introduction to Tongyuan. Tongyuan is founded in 2008 in Suzhou, China. We provide the MWorks products and also provide some engineering service. So now Tongyuan have some key industry, including aerospace, aviation, energy, shipbuilding, vehicle, communication, electrical, mechanical, and education. So now I will introduce the MWorks. This is the MWorks, the frame. So the MWorks support the CPS computing and simulation through the unified multi-paradigm modeling. That means we use the MWorks, the SysLab, which is a scientific computing tool to support the SIBE exam. And all the tutorial to support system modeling and simulation. We also developed a new tool named SysBlock to support the block diagram and the state machine. So the three tools together can support the CPS badly. And MWorks also supports the digital engineering from design, implementation, to operation and the maintenance of the equipment development. So this is the frame of MWorks. Firstly, we provide the three tools just mentioned to support CPS, modeling and simulation, the SysLab, SysBlock, and SysProria. We also provide some tools to support MBSE or digital engineering. The first one is the SysBuilder, which is a tool based on SysMail, and use the SysLab and the SysProria to support the verification of system model. And we provide new tools named the SysTwin to support the digital twin of system equipment. The SysLink is a collaborative tools that support the multi-users to modeling and simulation. So based on the basic software that the SysLab, SysProria, we also provide some toolbox to support different domains such as signal processing, communication, control, mechanical, fluid, electrical, and Hill simulation, and some interface. So MWorks is one to provide a unified multi-paradigm modeling pattern from the function, data flow, physical, ROM, and date. For example, we provide the function including Modelica, Julia, and C-code integration. The data flow is provided by SysBlock, supporting the block diagram and the state machine. We also provide the physical modeling based on Modelica. We also provide the tool named the ROM Builder to support the model of reduction. We also support the AI natural network to support based on data. First is the SysProria. Yeah, SysProria is the Modelica-based system modeling and simulation. It provides the full IDE for Modelica and support Modelica language verification, and the FMI word fashion. We have the high performance simulation software can generate C code and can import CD assembly into multi-body library, and provide some API to integrate the engine. So the SysProria have a high performance compiler we have, because we have been the Modelica for more than 15 years, 20 years. So now the MWorks supported the latest version of Modelica language specification, Modelica standard library, and FMI. In 2024, SysProria integrated the new kernel, which we have developed 5 years. So, and we have a result that means in compilation efficiency, 40% improvement, and in solving or simulation efficiency, we have a 40% increase. And since 2021, Explorer provides the licensing of compiler, Modelica compiler, to release Ignite. The other name is Ricardo. So we also provide some model library, including one basic library, 24 specialized library, and 20 industrial library. So as for the sysblock, in early, the sysblock is a part of the sysexplorer. At last, we take it as a separate independent tool. So the sysblock is based on Modelica, provided block diagram modeling and simulation. It can be it can generate embedded the code better, and they provide the breakpoint simulation and debugging. And we also the sysblock can also import a Simulink model. So between the sysblock and the Explorer, both them are based on the Modelica, and we use the same compiler and solver. We just use the Modelica annotation to support the block diagram modeling and debugging and simulation. So the below is an example. We can define the block of the port, the type and dimension are variable. So use the annotation. Maybe we will release the annotation standard later. As for the syslab, it's a Julia-based scientific computing. It has a complete IDE for Julia development. We also provide many library or toolbox. We provide, especially besides the Julia, the syslab also supports Python, MATLAB M language, and C+ language. The syslab can run the MATLAB M script directly without modification. So that means we have developed a compiler of M language. So in the past years, we have done much work based on Julia, such as the cloud-native scientific, the Julia IDE. We also support Julia, Python, MATLAB, M language. We have provided many libraries based on Julia, including mathematical, control, communication, etc. And we also, the Julia have some advantage in efficiency, but it has some disadvantage. So we do many work to improve the efficiency of Julia in startup speed and the debugging efficiency and the memory to reduce the memory occupation. We also provided the Julia static code generation. It was the first time it was provided in the Julia community. So we can, that means we can generate the C++ code based on the Julia and can employ the execution standalone. So especially I have mentioned, syslab can directly run the M scripts. So we have supports more than about 2,000 functions in MATLAB. So syslab provides some many mathematical library, including basic mathematics, symbolic mathematics, curve fitting, statistics, optimization, and global optimization. And also provide the control system toolbox, including control system toolbox, support control design, system identification toolbox, robust control, and model-based design optimization. We also provide some signal processing and communication toolbox, including signal processing, DSP system, wavelet radar, phased array system, communication, and RF. So all the toolbox have been used in industry, the real case. So the three tools, SysLab, SysBlock, and SysProria, we together support the CPS. Firstly, the SysBlock and SysProria were based on Modelica, have the unified compiler and solver. And between the SysLab and the SysProria, we use the shared workspace and provide the ability to interoperation or into call each other. So we can combine the sci part and the physical part together to simulation. So we also provide the full function to support code generation. So the Julia, based on Julia SysBlock, SysLab, and the SysProria and SysBlock can generate C code. SysBlock model and the generated code can be traced in both directions. Julia static code generation is developed also provided in SysLab. So we also provide some AI tools. We name the MWorks Copilot. The right is demo. So we can provide some coding Copilot and the modeling Copilot, and we want to support the Julia, MATLAB, and Modelica, the language. So we also provided the room-built tools to support the reduced order model from the FEM models to improve the efficiency to running. So based on the MWorks and the CPS ability, so we provide SysTwin to support the embodied intelligence, and this is a framework of this. So that means in SysTwin, we use the SysProria to construct the model of the body, of the robot body, and we provide some the poster engine to support the visualization. And about the sensing, planning, control is provided by the SysLab, and you can train it in the physical world. And the tools will be released in this year. This is some demo of some training based on MWorks. So last, we introduced the Modelica in China and some use case. Now, Modelica is very popular in China, especially in aerospace, aviation, energy, shipbuilding, vehicle, and education. There are many users. Through our endeavor on the Modelica, so Modelica has become the cornerstone of the MBSE or digital engineering application in China. That means we based on system tools build the product architecture, and then we use the Modelica to verify the design. So both of them can combine the design and verification closed loop. So I think it's the core of the MBSE or digital engineering. So almost the whole MBSE practice are based on such pattern in China. So we, in past many years, so MWorks has become forming the ecosystem for MWorks. Now, MWorks have 250,000 users, covering more than 30 industries, and we have 1,000 enterprise clients, and covering MWorks in more than 600 universities, mainly in China. So now we have 12 textbooks about MWorks have been published. And in this year, 100 more textbooks will publish in this year. And we also established the Open SCS, open source community, which is based on the Julia and Modelica. We want to form an open source and connect it to Julia community and Modelica community. So lastly, we'll introduce several applications. The first one is the Chinese space station. We have spent about 7 years to build the space station model, which include the 9 discipline, 100 and 600 devices, and contains 1.5 million equations. So it's a full model of space station, and it has been a digital twin with the real station, so support the permission ground simulation, comprehensive real-time in-orbit monitoring, and rapid operational status production. So this is a very classical application in MWorks. MWorks was used in civil airplane from the system modeling development, desktop virtual simulation, a full aircraft real-time simulation, and engineering simulator application, such as the AirJ21, C-Line 1 and etc. such civil airplane. And we also developed a tool for nuclear reactor named NUMAP, a nuclear reactor unified modeling and analysis platform. Based on MWorks, we expanded the ability of Modelica to support two-phase flow, so it can combine the nuclear dynamics with the mechanical and the electrical, the other domain together to support the system level modeling and simulation of nuclear reactor unified. This is the application of the NUMAP, which is a CT waste heat power generation. We support such model and can support the twin calibration, self-evolution, virtual operation training, twin operation, and some practical forecasting, etc. So now MWorks has been a complete scientific computing and the city modeling platform. In the Modelica conference, we have a form, oral, and a poster presentation, and has one tutorial, and this vendor presentation and the exhibition booth. So we have provided the English website and in Tongyuan.cc. Welcome to visit and download MWorks free. So that's all. Thank you, everyone.